morning, everybody. I'm heading into Wilmington, where I often go. Change out an air handler. We got an old Goodman air handler, I mean real old, like a 1988 Goodman model, matched up with a GMC outdoor unit that's old, but not as old. It's a rental property. They want to go ahead and change out the air handler because it has several different problems. It's kind of run down, leaking water. It's just a pain in the butt. So I'm going to change it out. I'm going to go pick up a key, I'm going to pick up the air handler, and we're going to get started. Here's our old Brayburn thermostat. Fan's running constantly. We had a failed fan motor relay on this unit. Water leaked down and actually filled the fan relay with water, believe it or not. Pretty much clean filter. We're going to open up this door to get to the air handler, and you can see the old beast. Looks like the old beast has been putting some water on the floor there too. There's our water on the floor. Hopefully we'll be able to, the floor doesn't look rotted out or anything at this point. We'll have to take everything up and see what's going on. Take this front board off. There's our old air handler. She's a beast. Got some ductboard on it, so that's good. We should be able to cut that off and just put a new sleeve on the other air handler and slide it up in there, and any gap we can insulate. Looks pretty good. Put a new float switch on the drain there. I blew it out before, but it appears that this thing has a few extra problems. It's been on a previous video. Can't remember the name of it. I think we're looking at a 1988 or 87 Goodman air handler. Time to go. We took our board off, and as you see, plenty of water down there. Carpet padding, got a little bit of water on it. It's kind of a nasty little situation. All the wiring's at the base of this air handler because it's counterflow, so not having a float switch over the years has really been detrimental, because it can flood that compartment and damage the components. And we're going to go ahead and pump this unit down so I can take it out, measure out and cut the ductboard off, and then get down to business putting in a new pretty air handler. Well, this is what I get into when I try to take the cap off the service valve. I get into a unit that's leaking so badly, the service valve is shot. There's going to be no way to preserve this valve with any sort of sealant. It's leaking so heavily. But that's what we get into when working with old stuff. So now I have to get into repairing the old stuff. Alright guys, we're taking our job to the next level here. After going outside, seeing the service valve, oh, there goes the phone. Anyway, we're changing out the whole system. Stay tuned. Alright guys, I took up the old unit, put down some metal, bent a flange down into the old ductboard, and mastic everything up so I can set the unit on top of this. Hopefully it'll form a pretty good seal there. That way we have a nice firm base, a nice good base, and we're not hitting wood directly with the air handler, which is against the code. So I put a little buffer in there, a metal plate down, and we should be good to go ahead and set the unit. Alright guys, our air handler is set. Took the coil out, connecting some of the ductboard, putting some flanges up there and sealing it up. And I put the face on there, then mastic everything up. And we'll be able to set the coil and start doing our piping and electrical connections. The copper's brazed in there, got some bends on it. Can't really see it far away. It comes down right there. Give me a little bit of room to work on the blower, because it's going to slide out if need be. It's our aluminum evaporator coil. Good to go. So I'm going to do the drain over here. We're going to pipe it down, put a little safety switch right here as it goes down, and then I'll be able to wire everything up, seal this unit up, and go get the outdoor unit. Alright guys, we're looking at our Goodman unit here. It's sitting on the pad. Got the risers underneath it. Get it off the ground a little bit. I have my temporary power hooked up to the disconnect. I'm using the breaker as a shut off, hooked up to my fan, so I'm nice and comfortable because it is very humid today. I'm about to fit up the copper and braze it in. Then we can do the electrical and low voltage. It's going to have to be a splice done in the low voltage, but it is what it is. I'm going to fit it up, get it brazed up, and y'all can check it out. We have our copper fitted up, a couple bends put on it, the yellow jacket bender. We have two swages at the end of the 3/8 and on the 3/4. And I know, I guess Justin just bought one of these tools. It's really cool. You're really going to like it because I hardly ever use fittings, except for the occasional street elbow where I don't have enough room to make a bend. But it works great. I'm about to braze it up, then we can pressure check. That's all brazed up. Took the cores out, took the caps off, The Goodman valve cover caps for the surface valves have O-rings in them, so you have to be careful with those too because they'll melt. Especially if you lay a little bit too much heat on the valve or if you're new to brazing. All welded up here. Use my shovel as a little fire barrier, just like a sheet of metal, but the shovel's already here, so we MacGyvered it into place. I'll put the cores back in when it cools down. We'll go ahead and pressure check. Hopefully we're good to go. I'll go ahead and put the orifice that comes with the outdoor unit with the air handler, but I think it's a 57, but I think it's already a 57 that comes with the air handler. But we'll double check that, get that ready, then pressure check. Guys, we got the tightness test on, 2 minutes and 22 seconds so far. We're gonna leave it on for a little while, assuming it's good. We'll move on to a vacuum. I'll go ahead and start insulating these copper lines. I don't typically insulate them until I make sure everything's not leaking, of course. Insulate them inside and out. I can seal up the air handler. Get things ready to start up here shortly. The vacuum now, we're down to about 400 microns. We're running for a few minutes. We'll let the vacuum pull all through the low voltage and high voltage. And then we can tidy things up before we give it a run through. When we started the system, we had a 370-pound head pressure over 160-pound suction. A little bit high. We had no superheat and almost 20 degrees of subcooling. The units are pretty close together, and I think probably this unit had a little bit more than the factory charge in it, if I had to guess. I don't think airflow is a factor based on temperature readings, high and low. I think we just had a little bit of an overcharge. So I'm taking a little bit out directly into the recovery tank using the high side pressure. We have 350 pounds on the high side, which is more than enough to force refrigerant into the jug. That is what I'm doing now. I've taken a little bit out so far, and the superheat's come up a little bit, but I like to see it above 10, probably between 10 and 15 would suffice. So that's what we're doing right now. I'm gonna take a little bit more out, we'll let it run for a little while, and then I am done. It's doing much better now. We have almost 12 degrees of superheat, 13 degrees of subcooling. Our pressures look a lot more like the conditions at hand. We have a wet bulb inside of roughly, between 67 and 68 degrees. It keeps falling. Last time I checked it was 68. We're at 88 degrees outside. Target superheat's right around 15 degrees. So we're about squared away here. Happy day. Oh, happy day. We have our nicely sweating suction line, our liquid line. Tested our motors as far as ampacity and voltage. Everything's good to go. So we are wrapped up here. We'll take one final look and we're done.